So in this video we'll be learning how to calculate the surface area. Now let's draw a graph to visualize what we are trying to calculate. So let's say we have an arc or a curve like this and we are rotating against the x-axis. So the entire 3D model will be something like this. And now we want to calculate the surface area of this arc. So this is a 3D arc shape, and this line is equal to y is equal to f of x. And now the formula states the surface area denoted by s is equal to the integration from a to b of 2 pi y is the function f of x, radical 1 plus f prime of x squared dx. Now we could rotate against the x-axis, or sorry, the y-axis, and this would be in terms of dy, and f of x would be in terms of y, and so on. So the same thing, but in terms of y. And you might realize that the formula that we just wrote over here, 2 pi radical 1 plus f prime of x squared, is the same formula for the arc length, except that we are just adding a y here. And y simply here is the function of f of x. So we are just replacing y with f of x. So now let's do some examples, and it will be more simpler to understand. So our first question is question 1. We are given the line 2y is equal to 2 radical x, and the limits are from 1 to 2, and we are rotating against the x-axis. Now what I like to do is always write the formula on the side, so I'm going to write it on the top right here. So integration from a to b, and 2 pi y, and then radical 1 plus f of x squared dx. So now let's find all the unknowns over here. So first step is to find the f prime. Since we have y, which is basically f of x, so f prime or y prime or f prime x is equal to, now we need to derive 2 radical x, so we bring half down, so it will be equal to 2 multiplied by half x half minus 1, so this will be negative half, and this will cancel out. So all we are left here with is x to the power of negative half, which can be written as 1 over x to the power of half or radical x. Now we need to find f prime squared, so we need to square both of the sides here. So f prime squared is equal to 1 over radical x, the radicals cancel out, and 1 squared is 1, so we are left with 1 over x over here. Now we have all the variables over here, so let's plug in the formula now. So I'm going to erase this over here. Now the formula is integration from 1 to 2, the limits which are stated over here. 2 pi, I'm going to take it outside, it's a constant, and we have y, which is basically the function over here, 2 radical x, and I'm going to take 2 outside also, so it's going to be 4 pi outside, radical x inside, and now we are left here with radical, don't forget about the 1 here, with the f prime squared, so it's 1 plus 1 over x, and this part here is, yeah, we already squared it, so we don't need to. So this is it. Now how do we simplify this integration? We know that radical a multiplied by b is equal to radical a times radical b. So here we have a as a radical x and b as this 1 plus 1 over x. So here what we can do is we can multiply each other in the radical, so we only have one radical left. So here let's do that. It's going to be I'm going to leave 4 pi for now, and the integration I'm going to simplify this for now. So this is equal to radical x into 1 over x plus 1. And now we can simplify this. This will cancel out with this. So we are left with the radical 1 plus x multiplied by 1 is 1. I mean x. So we can replace this entire thing now with, oops, let me leave that over there, radical 1 plus x. Now we can finally use u substitution over here to integrate. So let u be 1 plus x, and du here will be equal to 1 dx. So we can replace now dx with du, and this will be equal to 4 pi integration from 1 to 2 u to the power of half du. And now let's integrate this, so it will be equal to u 3 over 2 over 3 over 2. So I'm going to bring the 2 up, and we do have a 4 pi outside. We have the limits from 1 to 2, and don't forget that we need to substitute back u as what it is in terms of x to be able to use these limits. So here I'm going to replace u with 1 plus x to the power of, what was it, 3 over 2, yeah. Now let's replace now 2 and then 1, the limits. And here the final answer that you should get is 19.8. And that's it. So 19.8 is the final answer, and that's basically what surface area is. So now let's do an example where we rotate against the y-axis. It's the same thing, but in terms of y. So question 2 here is, we are given that x here is equal to 1 minus y, and 0, the limits are from 0 to 1, and we are rotating against the y-axis. So please pause the video and try to do this example yourself before we start with it. So as always, I like to write the formula. So the formula is limits 2 pi, and this time as it's in terms of y, it will be x here, since the function is denoted by x, and it is radical 1 plus f prime y squared dy. And yeah, limits of course 1 and 2, b, a and b I mean to say. So here let's find f of y prime. So f of y prime is going to be equal to 1 minus x. The derivative of 1 minus x is simply going to be minus 1, since 1 minus y, and y has the coefficient of 1 here, so minus 1, the 1 will come down, and 1 is 0, of course, the derivative of any constant is 0, and y to the power of 0, which is 1. So here we have minus 1 as the derivative. Now we need to square it, so square of f prime of y squared is going to be equal to 1. And now let's put it in the radical. So it is 1 plus f prime of y squared is going to be equal to 1 plus 1 is 2, and we have radical 2. So now let's place it in the formula. It is, the limits are from 0 to 1. I'm going to take 2 pi outside, and x here is going to be 1 minus y, and we have this entire part as is, so it's radical 2. And don't forget that we are integrating in terms of dy. So how do we simplify this now? So here, as radical 2 is a constant, we can just take it outside. So this will be equal to 2 radical 2 multiplied by pi, the integration from 0 to 1, and 1 minus y. So now we know how to integrate 1 minus y. this will be equal to, I'm going to simplify actually the integration first, so writing the entire thing again. It's going to be equal to, from limits from 0 to 1, y minus y2 over 2 with 2 radical 2 pi, and now we just substitute 1 and 0 here, and the final answer that you should get is radical 2 pi. And if you want to see the workings, I can also show that. So this part now, let's substitute 1 first. So this will be equal to 1 minus 1 squared over 2 minus, and now when we substitute 0 in this, it will be entirely 0. So that will be 0, and the final answer now will be 2 radical 2 pi, and this is half, so half cancels out here, and we are left here with radical 2 pi. So now let's move on to another example. Question 3. Y is equal to radical 2x minus x squared x minus x squared. Limits are from 0.5, x and 1.5, and we are rotating against the x-axis. So take a moment and pause the video. So here again, the first step is to derive y, or f of x. So this will be equal to 2x minus x squared to the power of half. I just like to not write it with the radical. So now let's bring half down and use the chain rule over here. So it will be 2x minus x squared to the power of negative half multiplied by 2 minus 2x. And now let's simplify this. This will be equal to 1 over 2, and this 1 can be replaced with 2 minus 2x, and we have a 2 into 2x minus x squared to the power of half. Pretty simple stuff. I just brought this down, and this is on the numerator, and we have a 2 in the denominator. And here another thing that we can do is we can factor the 2 outside for the numerator. So it's like 2 into 1 minus 1, or 1 minus x, and the 2 cancels out with 2 here. So all we left in the numerator here is 1 minus x. So it makes it more easier to square it now. So now we need to square the entire fraction. Let me erase that. So it is now 1 minus x squared over 2x minus x squared to the power of half, and then square. And if you don't know what we are doing over here, it's basically the formula 2 pi y and then radical 1 plus f of prime x squared. So this is why we are squaring it in dx. So here the half, the power of half or radical just cancels out the 2, and now we need to square the numerator. It will be equal to a squared minus 2ab, so 2a is 1 and b is x, plus b squared, x squared over, so let me write it again, 1 minus 2ab plus b squared over the same thing over here, since we just got rid of the radical. So now we got f prime x squared, and now we need to plus 1. So this entire thing plus 1. And is there a way to simplify this plus 1? What we can do here is we can have the same denominators so that we can simplify what we have. So here what I'm going to do is I'm going to make them the same denominator. So 1 can be also written as 2x minus x squared over 2x minus x squared, which is also equal to 1, right? And now we can merge them, so they have the same denominator. That's why we can add the numerators. So here the minus 2x will cancel out with plus 2x, and the plus x squared will cancel out with the minus x squared. So that is why it's more easier to simplify by making it the same denominators, and all we left here is simply a 1 in the numerator. So it is going to be 1 over 2x minus x squared, and that is our entirely this part without the radical. So now let's plug in the formula. So let me clear everything here, and all we left here with is 1 minus 2x minus x squared. So let me clear all this. So now let's plug in the formula. It's integration from 0.5 to 1.5, and let's take 2 pi outside, and now we have a y, so it will be radical 2x minus x squared into 1 plus f prime squared is our radical 1 over 2x minus x squared dx. And if you recall our first example, it was the property that you need to remember here is very helpful, is that radical a multiplied by radical b is equal to radical a times b. So here what we can do is we can merge them in one radical. So we will be left here with, let me move this to the right. I'm gonna leave the limits, everything. I'm just gonna take these two together down and simplify it. Radical 2x minus x squared over 2x minus x squared, which is equal to radical 1, which is equal to 1, right? So this entire thing can be replaced with just 1. So 1 dx. So again, this property is important, and all I did was I merged them into a radical, and it was a was basically 2x minus x squared, and b here is 1 over 2x minus x squared, and once you merge them it will just be the same denominator and numerator, which is equal to 1. So now all we need to do is integrate it. So the integration of 1 is x, and we have the limits from 0.5 to 1.5 of x. 2 pi is outside, so now let's substitute the limits. It will be equal to 2 pi times 1.5 minus 2 pi times 0.5, and this is equal to 3 pi minus 1 pi is equal to 2 pi. So the final answer is just 2 pi. So now let's do our last example, question 4, which is in terms of y this time. So x here is equal to 2 radical 4 minus y, and we have the limits from 0 to 15 over 4, and of course we are rotating against the y-axis. So again, let's find x prime here. So x prime here will be equal to 2. I'm gonna first write it in terms of the half power. Now I'm gonna bring half down, so it will be equal to 2 multiplied by half of 4 minus y negative half, and now we need to multiply it by the derivative of this bracket, so don't forget that chain rule, multiplied by the derivative of 4 minus y is negative 1, since derivative of minus y is negative 1. So here 2 cancels out to 2, and here all we are left with is minus 1 over 4 minus y to the power of half. So now let's square it. It's going to be equal to 1 over 4 minus y, since the square root of negative 1, square of negative 1 is 1, and here the radical just cancels out the square. Now we need to plus 1, don't forget that. So let's make them the same denominator again. So 1 can be written as 4 minus y over 4 minus y, to make it the same denominator, to add the numerators here. So now we have the final thing as 1 plus 4 minus y over 4 minus y, and we can just simplify this. It's going to be 5 minus y is equal to same thing, and this is entirely 1 plus f prime of x, sorry, y this time, squared n prime. So now let's plug in the formula. Let me erase everything here. It's going to be the integration of, I'm going to take 2 pi outside, and now the x here, the function is 2 into 4 minus y. So here we can take the 2 again outside. It's going to be 4 pi over here multiplied by radical 5 minus y over 4 minus y. Same, this thing over here, but we just have the radical dy. Now again we can say use the same property as before, and this will actually cancel out with this, so all we left here is 4 pi radical from 0 to 15 over 4 of radical 5 minus y dy, and we can take u as 5 minus y, du is going to be equal to minus 1 dx. So now I'm going to take negative 1 outside, so negative 4 pi integration from 0 to, okay, I'm going to leave that for now. So it's going to be the integration from u half du, so u 3 over 2 over 3 over 2, and don't forget to substitute u as what you replaced it from before, so it's going to be 2 into 5 minus y 3 over 2 over 3. So now I'm gonna replace this part, or this part actually, with the limits now. So 0 to 15 over 4 of 2 into 5 minus y 3 over 2 the power over 3. And now we simply substitute both of the limits. So now let's substitute the limits. Is going to be equal to, I'm going to take the 2 outside here, so it's going to be minus 8 pi and 5 minus y, which is going to be 15 over 4 over 3, and actually this is to the power of, or sorry, this entire thing is to the power of 3 over 2 minus, and then again we have minus 4 pi, so this becomes plus, and I'm going to again take the 2 outside here, so it's going to be 8 pi open brackets 5 minus 0 to the power of 3 over 2 over 3. So now this is equal to, if you type on your calculator, the final answer that you should get is 81.95. So as always, I do have a shortcut method for you guys. So in your question, all you have to do is you need to find x prime. That's it. So once you find x prime, you can just apply, open your calculator, and you should of course have the integration on your function, integration function on your calculator, and then you just need to plug in the formula, which is, you have the limits, which is 0 to 15 over 4, and then you have 2 pi out in, and then multiplied by the function. So you just type as is what the function is, which is 2 into 4 minus y into the radical, which is equal to 1 plus f prime. So you type f prime in brackets, which here in our case we got, I don't know what we got, but whatever we got, we square it, and that's it. So you will get the final answer, which is 81.95. And this way you can recheck your answer, or if it's like a MCQ question, you can directly find the final answer like this. So it comes in handy if you made any silly mistakes or any thing like that. And I will be making a short video on how to do that shortly. And thanks for watching. If you have any questions, you can always ask in the comment section. I'll be more than happy to answer, and see you guys.